All right, so this one talks about the midpoint of an isosceles triangle. Okay, so I think I did this at tutorial with someone yesterday. So this is got no figure and they want us to write a coordinate proof. So again, when I go over this eventually tomorrow, there might be more than one answer for this. Okay, so you guys have the segments joining the base vertices of the midpoints of the legs of an isosceles triangle are congruent. Okay, so let's say they're referring to the base. So I'm going to go ahead and put the base on the x-axis. You generally want at least one of the vertex of the triangle on the origin, and then for sure one of the sides of the triangle should be lying on the line. Sorry, Christian, I'm not sure what that's referring to. The ITT. Lying on. So this is the base. And they want me to, and then they mentioned something about the legs of the isosceles triangle. It does not say that it has to be a right triangle. So I'm not going to mark that as a right triangle, but this is an isosceles triangle. And so then they also mentioned that the segments joining the base vertices, I'll highlight what that means. This is the base vertices. This is the base of the isosceles triangle, base vertices, connecting that to the midpoint of the legs of the isosceles triangle. So if these are the legs, then let's go ahead and identify where the midpoint would be. So let's say this is the midpoint, this is the midpoint, and we're just roughly guessing where that is. And so if you connect the segments, so they want you to show that this segment is congruent to this segment. No, I think just for that reason, I would say just say base angle theorem or converse of it, or isosceles triangle theorem, and then converse of it. Otherwise, I wouldn't know, the reader wouldn't know what you're saying. All right, so after you sketch the picture, have an idea of what it is that they want, the next step would be to label the coordinate points that you see. So let's say this is triangle ABC. Coordinate point A is on the origin. Coordinate C, let's say, is some unit of measure over. And so let's say I just define this. So this part is the part that could be different depending on the person who decides this. So if the textbook doesn't tell you, you make it up. And since they're referring to midpoints, I might have to take half of this. So I'm going to go ahead and call that 2A. And then comma, this is still on the x-axis, so the y-coordinate is 0. Okay, if I'm trying to decide B and this is an isosceles triangle, then I know B, this coordinate point falls directly above the midpoint. So what would the coordinate point be here for B, for the X value?
1A.
Okay, 1A, perfect. And then technically, you guys don't know if your isosceles triangle goes up this high, this low, or where I have it. So that's a new value. The height of it, that Y value, is going to be something else. So I'm just going to call it B. So again, someone said, I use different variables. I use X, I use Y. It's that part of it is going to be entirely up to the individual, but the steps following that should lead to the same conclusion. So if they want me to show that these two are congruent to each other, what do you guys think you have to do to, oh, and also I noticed I didn't assign this coordinate point yet. So let's call that one X and this one Y. So basically the midpoints. Okay, so if you're looking at X and you want to find the midpoint of B and C, what you would do would be add 1A and 3A. Or sorry, 1A and 2A to get 3A, and then you divide it in half. Do the same thing for the Y's, B over 2. And then for the coordinate I called Y, you would add A and 0, and divide by 2, and then B and 0 and divide by 2. So we have A over 2, B over 2. Lucian, I think you asked this question. Are you okay so far with what I just did, labeling those coordinate points?
Yes, I am. Thanks.
Okay. So then after that, you guys, of the formulas that you guys have, you have midpoint formula, you have distance formula, and you have the formula for slope. If they want me to show that these legs of these triangles are congruent, how do you guys, which formula do you guys think you need to use for that? If you're trying to show the sides are congruent, what do you think you have to use for that? Yeah, you have to use anything what to do with length is distance formula. So what we're going to do is do the distance formula and find the length. Actually, instead of calling it d, I'm going to call it the length of x c, which is this one right here. We're going to do that one first. And the distance formula is change in x over change in y. So let's say 2a is bigger than 3a over 2. So I'm going to make that 2a 4a over 2 minus 3a over 2. 4a over 2 is the same thing as 2a. I just did over 2 to make it a common denominator at the same time, squared, plus 0 minus b over 2 squared. So again, change in x squared, change in y squared. Okay, so then from there, you guys get, and really it doesn't matter that it's not nice and pretty here, but 4a minus 3a is 1a over 2 squared. And then plus over here, you guys have b over 2 squared, which is plus, if you square that, it's deciding on how far I want to go here, b squared over 4. So this one is the square root of a squared over 4 plus b squared over 4. So that's currently what we have. We can't go any further with this. Well, I guess we could take the square root of the bottom, but let's just say right now the goal is, if we take the look at the big picture, is to show that the expression I get for this should be the same as the expression I get for the segment YA. Like, so those two should be the same things. So now the other side is a little bit easier. So if you guys do the distance formula between y and a, you have your subtracting 0. So it's a over 2 squared plus b over 2 squared. We see here that we end up with the same exact expression. And by the way, you guys cannot square root each one of these individually. So that's as far as you guys can go. Some people might split the square root on top and bottom, but it's not necessary. From here, you guys can tell that this is going to be equal to this. That's what we're attempting to show. So since, let's summarize it. So since x c is equal to ya, the midpoints, I would just restate the what the question is asking for. So the segments of joining the base vertices to the midpoints of the legs of an isosceles triangle is congruent.